Hey there, hackers! Welcome to Tacit Sanctuary. I am bringing you the joy of array programming using the Wewa language. So, today is the 29th of February, and it's a perfect opportunity to tackle a problem which involves leap years. So, this coding challenge was published on Exorcism as the first part of their 2024 coding challenges. So, what we have to do is check whether a year is a leap year or not. So there are some specific rules to do this. If the number is divisible by 4, then it is a leap year. However, if it is divisible by 100, then it is not a leap year. But still, if it is divisible by 400, it is a leap year again. If you want to check how to solve this in other languages, Exorcism has a great video on it on YouTube. What are the possible approaches? The basic idea is that this is a very simple problem to solve using if-else branches or if-else conditions, but we are going to take a different approach here. So this is my Wewa solution, and I am going to explain how it works using the online editor of the Wewa language. Okay, so let's start with this problem. So basically, we are going to write a function that returns a Boolean value, a true or false value. So in Wewa, we do not have a Boolean data type. We have 1 and 0 representing true and false. So to decide if a number is divisible by another one, we can use the modulo function. So if you don't remember the names of the functions, you can just hover the cursor over the toolbar and you can figure out the name. You don't have to type the actual symbols. It is enough to type the name of the function and then the formatter will automatically convert it. I want to check if 2000 is divisible by 4. Then I'm pushing the number 2000 to the stack. Then I'm going to push the number 4 on the stack. Now we can see the output here. If I press Ctrl and Enter, then the code will automatically run for me. Then if I perform this modulus operator, I can either click the symbol or I can type the name. I do not even have to type the whole name. It's just a couple of characters are enough for the formatter to distinguish what I want to do here, and it will convert to the symbol automatically. Basically, this is telling me that if I divide 2000 by 4, then the remainder is 0. So if I go with 2001, the remainder is 1, and so on. Okay, I don't even have to add white spaces here, so I can compress the code a little bit like that. Wewa code is typically read from right to left and from top to bottom. Wewa is an array language, so we can take advantage of that. We can perform the same operation on each element of an array at the same time. So, for example, I can take the modulus of 2002 by 4, by 100, and 400 at the same time. So how can I create an array? So there are basically two main choices. I can use the angular brackets. So, and I just list the numbers and they will create an array for me. Or I can put an underscore between the numbers and it will have the same effect. This is creating the same array. So if I write here modulo 4, 100, and 400, then it will calculate all those modulo numbers for me. So for example, if I test it with 2100, it tells me that it is divisible by 4 and by 100, but not by 400. So there is one simple trick how we can convert any number, any remainder number that we have here to a logical or Boolean value. And this is by taking the sign of this number. So the sign is showing me whether it is negative, 0, or positive. This is the function on here. So if you hover over it, it will also tell you what is the expected output. And basically, if you want to know more, you can just shift click or control click in any of the functions and it will guide you to the documentation. Okay, so if I take the sign, I'm going to have an array of ones and zeros. This means that my number is divisible by 4 and 100, but not divisible by 400. So here we have three numbers, ones and zeros. So how many total choices do I have? How many possible combinations? 2 to the power of 3. So that is basically 2 times 2 times 2, that is 8. But to be fair, we do not have 8 different outcomes. We actually only have 4 possible outcomes because when a number is divisible by 400, it is also an evidence that it is divisible by 100 and it is divisible by 4. And on the other hand, if it is not divisible by 4, then it cannot be divisible by 100 and 400 either. So what are the outcomes that are favorable for us that indicate a leap year? Divisible by 4 means that the output is 0. So we should have 0 here. And if it is not divisible by either of those two numbers, then we are just going to have 1 and 1 in the next spots. So for example, with the number 2004, this is the outcome, and 2004 is a leap year. Another possibility is the number 2000, which is also a leap year, because even though it is divisible by 4 and 100, but it is also divisible by 400. So in that case, the outcome is 000. So these are the favorable outcomes. And basically, I can check if the result is one of these using the member function. So the member function works like this. The first value on the stack should be the array, and the second value is the member or the potential member. And if it is included in the array, then we will get a 1, otherwise it is a 0. Okay, so if I want to see if the result is member of either of these two values, then I will put here member, and I can take this and put them in an array. And the value that I want to check is already on the stack. So if I actually run this right now, this is not giving me the result that I want because I have to switch the two values on the stack. If I just remove it, now I have the result of my previous computations. And then on top of that, I have my two-dimensional array of the possible acceptable outcomes. So if I want to change the sequence of the argument for the membership function, I can use the flip operation, and it will just change the location of these last two elements on the global stack. And now I can use my membership function to check whether it is a leap year or not. And for 2001, it is going to tell me no, 2002, no, 2004, yes. And 2100 is not a leap year because it is not divisible by 400. So this is working fine. Okay, but this code is a little bit unwieldy. So I want to show you a little trick that can make this code much more compact. So what is this three dots function? So actually, this function is able to convert a number to its binary representation. For example, let's say 42, and it is called bits. If I say bits 42, then it will show me the binary value of this number. So ones and zeros organized in an array in a way that the first bit is the lowest priority. So this represents a 1, represents a 2, a 4, an 8, 16, and a 32. And the beautiful thing about it is that I can also do this conversion backwards. So if I have a binary array, I can convert it to a number. To do this, I use this AND operator. This is one of the genius tricks of Uiua and also of other array languages, that I can reverse an operation, a mathematical operation, or even a structural change to arrays. If I use AND bits, on this result, I will get back the 42. So the formatter will recognize it, and the result is 42 again. Okay, so this is perfect. How can I figure out what is the number that corresponds to these binary sequences? I take this array and I just apply AND bits over it, and it's going to tell me 6 and 0. So this is what I have in this code, 0 and 6 organized in array. I can use this notation or that notation, it doesn't make any difference. So let's just change this to 6 and 0. And yeah, before that, I have to actually apply the AND bits part. So this is now working. These are my acceptable outputs. I remove this comment because I don't need this anymore. Now I have two lines, and this is a trick in the editor that if I put here an apostrophe, it will read the line along those two sides of the apostrophe so that I will have shorter lines and the code is organized in a top-down fashion. I can also merge two lines in this editor using the two apostrophes. And now everything goes from right to left. This can be considered a function. So I can give it a name before I put any value on the stack. If I just execute this, it's not going to work because there are not enough values on the stack at this point. But I can assign this expression to a name. For example, leap year. I can use the equal sign and it will be converted to a nice arrow that marks a function. So if I hover over it, I even get documentation what it does. It is taking the command from the rows on top of this function. So this is a way we can write documentation to our code. And the first part of this pop-up is a vertical bar with the 1.1. It means how many arguments it takes and how many arguments it returns. This is very helpful because now we can understand how many values we need to have on the stack for this function to work. And if I run this code now, nothing happens, there is no output. So I have to give it some arguments. Leap year 2000. And it gives me 1. I can just remove this now because now it's exactly the same code. How can I test it with more than one number, right? So if I try this, I use an array and apply leap year on it, it's not going to work because there is some conflict in the shape of the data that I'm using. But I don't want to run the leap year for this whole array. I want to run it for each value separately. So for this, we have the each operator. And now it's telling me that 2000 is a leap year and 2001 is not a leap year. So how can I do it with more than two values? I can create a range of consecutive numbers. For example, range 8 is going to give me 8 numbers from 0 to 7. I can add, okay, let's say 1998. So this is a nice range to test my function. I put this on top. I remove the previous test data and I can get the result like that. So if I also want to see what were the initial values, I can just duplicate this value, this array that is on top of the stack by using this dot operator. And then I have the original values and the result as well. So the third value here is a leap year and the seventh value is also a leap year, 2000, 2004. If we test it with 2098, then 2100 is not a leap year. So now if I want to see the original values and the results arranged in a more friendly format, I can basically couple these two arrays and it will show me the value and the result next to each other. If I want to reverse the order, I can also flip them. And I can even do a transpose. Transpose is this rainbow colored icon here. Then I will see the values next to each other. So this was the solution of the leap year problem. I hope you enjoyed it. See you next time.